Hello everyone. Let's look at graphing the polar equation r equals 4 cosine of theta. Now with graphing a question like this, as with other polar equations, sometimes it helps to put it into rectangular form. It allows us to get a better idea of it. So the first thing I can do is I will take, and I want to get this so I can apply one of my conversions, which are x equals r cosine of theta, y equals r sine theta, or r squared equals x squared plus y squared. Some of the more common ones. If I multiply each side by r, I'll get r squared equals 4r cosine of theta. Now I can make a couple substitutions. My r squared becomes x squared plus y squared. This becomes equals 4x. So in rectangular form, I have x squared plus y squared equals 4x. Now I can take this and I can solve as if it were a quadratic equation. In other words, what I can do is I can get all my terms on one side, I can look at this as a conic section. X squared minus 4x plus y squared equals 0. I can solve by, I can complete the square for my x's. So I'll add b over 2, so negative 4 over 2 squared gives me 4. So add here, and when I factor, I'll get x minus 2 squared plus y squared equals 4. This goes back to completing the square using conic sections. In this case, our conic section happened to be a circle. So this tells us that we have a graph of a circle with the center under a translation of 2 to the right. So we have a circle with the center at 2, 0. And then if you recall our equation for a circle, the square root of this constant, 4, is our radius. So a circle of radius 2 with that center looks something like this. And there's our graph. So a lot of the connections to conic sections with a question like this. Another way of looking at it is if we were approached by the old XY method from earlier courses, where now going back to the equation itself, r equals 4 cosine theta, where I pick values for theta, as you can see, and then when I plug them into cosine, multiply times 4, you can see what I get. Plotting those points, so for example 0, 4 puts me right here. Four out, angle of 0. Pi over 6, that's this first one right here. So there's pi over 6, and I go out a distance of 2 square root of 3, which is about 3.46. Pi over 4, right here, 45 degrees. I go out 2 square root of 2, which is about 2.8. So right there. Pi over 3 is 2. Go out 2, so you can see it go out shorter each way. Pi over 2, straight up, at a distance of 2, or excuse me, a distance of 0, so it's right here at the pole. And then if I do the opposite now, if I do 2 pi over 3, 120 degrees, normally that would put me into quadrant 2, but because when I evaluate that, I get a negative 2. Recall when I graph a polar point, the negative takes it in the opposite direction, so it takes me instead right here, a distance of 2. Same for 3 pi over 4. While that is in quadrant 2, the negative 2 root 2 takes me back in the opposite direction, over here. And the same with 5 pi over 6. So what I've created again is like before. There's my circle in the same position as it was here. And we'll still have a point of 2, 0 in the middle. So what this leads us to, we can use, of course we can put in values for theta, we can use complete and square and rectangular coordinates. In general, what we find is for a graph such as this, anything in the form r equals some value times sine or cosine, it can be broken down to these two categories. R equals 2a sine of theta, or r equals 2a cosine of theta. And they have very similar properties. For 2a sine of theta, circle, oriented along the pi over 2 axis. Remember, that is the equivalent of the y-axis in a polar graph. So if I had r equals 6 sine of theta, this is my polar axis, here's my pi over 2 axis. So oriented there means it's going to be along that axis. It's going to cut it in half. A radius of absolute value of a. So in other words, 2a sine of theta implies that 2a is 6, which means our a value is 3. So if I go 3 up, 0, 3 is my center, and a circle with radius 3 along the pi over 2 axis. So oriented along the axis means that axis cuts that circle in half. As cosine is oriented along the polar axis, you can see the horizontal axis or the polar axis cuts it in half. Likewise with cosine, whatever that number is, whatever the coefficient of cosine is, or sine, we're going to equate that to 2a. That will allow us to determine our radius. If it's cosine, it's oriented along the polar axis, and the center is at 0 plus or minus whatever a is, 0 plus or minus a. So these are the generalities we can use. Anything in the form r equals some value cosine or sine of theta.